In this video, we will explore the essential steps for identifying and replacing faulty sensors in a UAV. Why is it important? UAV sensors, such as the gyroscope, accelerometer, magnetometer, and barometer, ensure stability and correct navigation. Their malfunctions can lead to flight errors, loss of control, or even the drone's crash. We will analyze the signs indicating a faulty sensor, the correct diagnostic methods, and the replacement process to keep the UAV in optimal working condition. Signs that a UAV sensor is not functioning correctly. The UAV tilts uncontrollably, vibrates, or responds slowly to commands, with the responsible sensor being the IMU. Orientation problems. The UAV does not maintain the correct direction, with the responsible sensor being the magnetometer. The altitude suddenly changes without reason. The UAV climbs or descends uncontrollably, with the responsible sensor being the barometer. Frequent signal loss, large positioning errors, with the responsible sensor being the GPS. The UAV does not detect obstacles, brakes unnecessarily, or does not respond. The responsible sensor is the optical sensor. How do we perform correct diagnostics? We connect the UAV to the configuration software such as Betaflight, Mission Planner, or DJI Assistant. We check the sensor tab to see if there are any errors or incorrect data. If the sensor is unresponsive, we check the connectors and wiring before replacement. Tools needed for replacement: precision screwdriver, extraction pins for connectors, soldering gun, and solder if the sensor is soldered. Anti-static tweezers, multimeter for checking voltage. Materials needed: compatible replacement sensor, double-sided tape, or damping pads for IMU. New cable if the old one is damaged. Thermal paste for certain IMUs and barometers. Sensor replacement procedure: replacing the gyroscope and accelerometer IMU. The gyroscope and accelerometer are integrated into the IMU, and in case of a malfunction, the entire module is replaced. Replacement steps: disconnect the UAV power and remove the battery. Open the casing and locate the flight controller board. Identify the IMU sensor, which is usually a small square module with a protective layer. If it is mounted on damping pads, gently remove it. If it is soldered to the PCB, use a heat gun to detach it. Install the new IMU by applying damping pads or thermal paste. Connect the UAV to the software and calibrate the new sensor. Replacing the magnetometer. The compass is affected by electromagnetic interference. If it is not functioning correctly, replace the sensor and reposition it. Replacement steps: locate the magnetometer, usually mounted near the GPS. Disconnect it from the flight controller, usually the I2C or SPI connector. Install the new sensor, ensuring it is distanced from the power cables. Connect it to the flight control and calibrate the compass. Replacing the barometer. The barometer is a sensor sensitive to dust and temperature. If it provides erroneous data, it must be replaced. Replacement steps: locate the barometer on the flight controller board. If it is soldered, use a heat gun to remove it. Install the new barometer and apply foam protection over it. Restart the UAV and check the altitude data. Replacing the GPS module. If the GPS is not receiving satellites, It may be faulty or the antenna may be damaged. Replacement steps. Identify the GPS module, usually mounted on an arm or at the top of the UAV. Disconnect the GPS cable from the flight controller. Mount the new module and fix the antenna in an open position towards the sky. Turn on the UAV and wait 5 to 10 minutes for the first GPS fix. Replacing LiDAR or ultrasonic optical sensors. These sensors are used to avoid obstacles and maintain altitude. If the UAV does not detect objects correctly, replacement is necessary. Replacement steps. Locate the faulty sensor, usually mounted on the underside or sides. Check the wiring for errors or ensure a stable connection. Unscrew the sensor and mount the new module. Connect it to the flight controller and perform an obstacle detection test. Testing and calibrating new sensors. After installing a new sensor, it must be calibrated and tested before the first flight. General calibration procedure. Connect the UAV to the dedicated software. Access the calibration tab and select the newly installed sensor. Follow the instructions for each sensor. For the compass, the UAV must be rotated in all directions. Save the settings and perform a ground test. Lift the UAV to a low altitude and check stability. If the sensor continues to have problems, check compatibility with the flight controller. Check the wiring and connectors. Recalibrate the sensor. Conclusions and useful tips. Only use sensors compatible with the flight controller for your UAV. Perform all replacements in a clean and dry environment. Calibration is required after replacement for stable flight. Keep sensors protected from dust, mechanical shocks, and electromagnetic interference.